In this video, we will solve a problem on utility maximization. The question is, given utility function is u is equal to x1 times x2 square minus 10x1. U denotes the utility. X1 and x2 are the two goods. Okay. And the budget constraint is 2x1 plus 8x2 is equal to 116. That means price of good 1 is 2, price of good 2 is 8, and total income of the consumer is 116. We have to find out the utility maximizing combination of good x1 and x2. Okay. So we are being told to find out the utility maximizing combination. That means we want to maximize this utility function subject to this budget constraint. Okay, so maximizing this utility function with subject to the budget constraint. Now, given the below budget constraint, this line, consumer wants to reach to the highest possible indifference curve, and the optimal bundle will lie at a point where the indifference curve and budget line are tangent to each other. Let us say this is the point, and it is a point where our marginal rate of substitution between good x1 and x2 is equal to the ratio of the prices p1 upon p2. This condition is fulfilled at the tangency between indifference curve and budget line. That's what I have written here. First order condition for maximization requires the marginal rate of substitution between two goods should be equal to the ratio of the prices, that is P1 upon P2. Price of good X1 is 2, price of good X2 is 2. Sorry, it is 8 here. So that means MRS should be equal to P1 upon P2. MRS is simply the marginal utility of good x1. Okay, so MRS means marginal utility of good 1 divided by marginal utility of good 2. Marginal utility of good x1 upon marginal utility of good x2 should be equal to the ratio of the price. MU1 means the partial derivative of a utility function with respect to good x1. Okay, so this partial derivative denotes marginal utility of good x1, and this partial derivative denotes the marginal utility of good x2. Okay, so let me repeat it here. Actually, the condition is that marginal utility of good x1 divided by marginal utility of good x2 should be equal to the ratio of the prices. Okay, so the mu1 means the partial derivative of utility function with respect to x1, and mu2 means partial derivative of utility function with respect to x2 should be equal to the ratio of the prices. Okay, so differentiating this function with respect to x1, derivative of x1 is 1, so we are left with x2 square. Here derivative of x1 is 1, so we are left with 10. So du upon dx1 comes out to be x2 square minus 10, and du upon dx2 comes out to be twice x1 x2. And derivative of x2 square is twice x2, so we have twice x1 x2, and derivative of a constant here is 0 because it is assumed to be constant. We are taking partial derivative with respect to x2 here. Okay, so solving this, we get solving it for x1, so x1 will be equal to 2x2 square minus 20 divided by x2. After that, what we do, simply plug the value of x1 back into the budget constraint. So when we plug the value of x1, so we have 2 times the value of x1 is this step, 2x2 square minus 20 divided by x2 plus 8x2. This 8x2 should be equal to 116. Multiplying this 2 to each of these terms, so we have 4x2 square minus 2 20s are 40 divided by x2 plus 8x2 divided by 1. So we can write 1 here for cross multiplication, should be equal to 116. Cross multiplying here, we get 4x2 square minus 40 plus 8x2 into x2 is x2 square divided by x2 should be equal to 116, which gives us 12x2 square minus 40 is equal to 116. Transposing, it will get multiplied here. Okay, is equal to 116 x2. Solving again. Okay, transposing this term to here, it will become negative, so we have 12x2 square minus 116x2 minus 40. This is a standard quadratic function here. Okay, using the quadratic formula. The quadratic formula is simply, let me write it here, that is the value of x2 is equal to minus b plus minus b square minus 4ac divided by twice a. Okay, the value of a is the coefficient of x square, which is 3 here. Okay, the coefficient of x2, which is denoted by b, is minus 20, and coefficient of the constant term is here minus 10. Using quadratic formula here, the value of x2, we will get two values here, that is 29 plus minus 31 divided by 6. That means we get the value, two values for the x2. One is positive, that is x2 will be equal to 29 plus 31 divided by 6, which comes out to be 60 upon 6, which is 10, and another value will be negative, that is 29 minus 31. So that is negative, we will not take that very stuff here, because negative quantity cannot be negative. Okay, so we got the optimal value of good x2 is equal to 10. To find the value of x1, simply plug the value of x2 in this equation again to get the value of x1. Okay, so x1 will be equal to 2 into x2 square, means 10 square, which is 100, minus 20 divided by 10. That means the value of good x1 will be equal to 18. That means optimal consumption bundle will be 18 and 10. Okay, I hope I make myself clear in this video. Thank you.